Good morning, friends. Today we study the point length element in curvier coordinates. Okay. In last lecture we have studied curvier coordinate system, that means general curvier coordinate system, and in that we have taken the definition of curvier surfaces, curvilinear curves and curvilinear axis. Okay, and in curvier coordinate system there are three coordinates, that is u1, u2, u3. So they are called curvier coordinates. Okay, so in this lecture we are going to obtain length element in curvier coordinates, right? So first we consider the position vector r bar. Okay, the position vector r bar of point P having coordinate x, y, z. Okay, so the position vector r bar of point P having coordinate x, y, z can be written as r bar equal to x I cap plus y j cap plus z k cap. Right? Now this Cartesian coordinate x, y, z are related with point P. So the position vector r bar in terms of curvilinear coordinate u1, u2, u3 can be expressed as, so right here, coordinate u1, u2 and u3. So here we have to write position vector r bar in terms of curvilinear coordinate u1, u2, u3. Okay, so we write here r bar equal to x of u1, u2, u3 I cap plus y u1, u2, u3 j cap plus z u1, u2, u3 k cap. Okay, so write this r bar equal to r bar of u1, u2, u3. Right here, r bar equal to r bar of u1, u2, u3. Right? Then the displacement of point P to P dash can be written as r bar equal to r bar plus d r bar. So here we have to displace point P to P dash. So the displacement is written as r bar equal to r bar plus d r bar. Here this d r bar is the total differentiation. So we write this d r bar equal to delta r bar by delta u1 du1 plus delta r bar by delta u2 du2 plus delta r bar by delta u3 du3. Okay, so here this delta r bar by delta u1 delta r bar by delta u2 and delta r bar by delta u3 are the partial differentiation of r bar with respect to coordinates u1, u2 and u3. So write this, that is d r bar equal to summation I from 1 to 3 delta r bar by delta ui dui. So let this equation first. Right? Now in this case, this delta r bar by delta u1 is the partial differentiation. So this partial differentiation can be obtained when the point P is moved along curve u1. Right? That means partial differentiation of r bar with respect to u1, with respect to u2 and with respect to u3 can be obtained by moving point P along u1 curve, u2 curve and u3 curve. So this del bar r bar by del bar u1 is the tangent to the u1 curve. So this we write del bar r bar by del bar u1 comma del bar r bar by del bar u2 and del bar r bar by del bar u3 are the tangent to the u1 curve, u2 curve and u3 curve. Okay, so write this, that is del bar r bar by del bar u1 equal to mod del bar r bar by del bar u1 into e1 cap, where this e1 cap is the unit vector along u1 curve. Similarly, write del bar r bar del bar u2 equal to mod del bar r bar by del bar u2 into e2 cap and del bar r bar by del bar u3 equal to mod del bar r bar by del bar u3 into e3 cap. So next this equation, second, third and fourth. Further, we substitute the value of mod del bar r bar by del bar u1 as h1. So right here, hence we put del bar r bar by del bar u1 what equal to say h1, then del bar r bar by del bar u2 mod equal to h2 and mod del bar r bar by del bar u3 equal to h3. Right? So with this substitution we can write this equation second, third and fourth like del bar r bar by del bar u1 equal to h1 e1 cap, del bar r bar by del bar u2 equal to h2 e2 cap and del bar r bar by del bar u3 equal to h3 e3 cap. Okay, so in next step we have to write the length element, that means length element in curvilinear coordinates. So write length element, that is dl square equal to dr bar dot dr bar, that is equal to summation I from 1 to 3 del bar r bar by del bar ui dui into summation j from 1 to 3 del bar r bar by del bar uj into duj. Okay, so write this equal to summation I from 1 to 3, then summation j from 1 to 3 del bar r bar by del bar ui into del bar r bar by del bar uj to dui duj. Okay, so this is the length element, that is dl square equal to, right? Further we substitute del bar r bar by del bar u1 into del bar r bar by del bar uj as gij. So right here gij equal to del bar r bar by del bar ui into del bar r bar by del bar uj. Okay, here this Gij is called metric coefficient. Right here, Gij equal to or is called metric coefficients. Okay. Now here we have written mod dabba r bar by dabba u1 equal to h1, mod dabba r bar by dabba u2 equal to h2, and mod dabba r bar by dabba u3 equal to h3. So this h1, h2 and h3 are called scale factors. And this E1 cap, E2 cap and E3 cap are called unit vectors. Here E1 cap, E2 cap and E3 cap are the unit vectors. Okay. So here we have written Gij equal to dabba r bar by dabba ui into dabba r bar by dabba uj. So right here G11 equal to dabba r bar by dabba u1 bracket square by putting I equal to 1 and j equal to 1. Similarly, we write G12 equal to dabba r bar by dabba u1 dabba r bar by dabba u2. Okay. Then G13 equal to dabba r bar by dabba u1 into dabba r bar by dabba u3. Similarly, we write G22 equal to dabba r bar by dabba 2 bracket square, right? Then G21 equal to dabba r bar by dabba u2 into dabba r bar by dabba u1, and G23 equal to dabba r bar by dabba u2 into dabba r bar by dabba u3. Okay. So next we write G33 equal to dabba r by dabba u3 bracket square. Then G31 equal to dabba r bar by dabba u3 into dabba r bar by dabba u1, and G32 equal to dabba r bar by dabba u3 into dabba r bar by dabba u2. Okay. So we have obtained here metric coefficients G11, G12, G13, then G22, G21, G23 and G33, G31 and G32. So we substitute these values in length element. So here we substitute the values of metric coefficients. So the length element can be written as dl square equal to G11 du1 square. So right here this here is du1, dui and duj. So substituting 1 1, so that is du1 square, then plus G12 du1 du2 plus G13 du1 du3 plus G22 du2 square plus G21 du2 du1 plus G23 du2 du3 plus last is G33 du3 square plus write the next G31 du 3 du1 plus G32 du3 du2. So name this equation. Next number, that is 5. Okay. So this is the length element in curvilinear coordinate system, right? Now further we have to write this length element in orthogonal coordinate system. Okay. So this equation 5 is called as the length element in curvilinear coordinate system. Here we consider this Gij as a metric coefficient. So we write this metric coefficient in the form that is Gij equal to, right, G11, G12, G13, then G21, G22, G23, G31, G32 and G33. So this is the presentation of metric coefficient in determinant form, okay, or in the metric form. So next we define orthogonal curvilinear coordinate system or orthogonal coordinate system. Orthogonal coordinate system. So first we have to define what is meant by orthogonal coordinate system. The definition is the orthogonal coordinate system is the system for which tangent drawn to the coordinate curve are mutually perpendicular to each other. Then system is said to be orthogonal. Okay, that means when we have to define orthogonal coordinate system, so it is the system in which tangent drawn to the coordinate curves are mutually perpendicular to each other. The system is said to be orthogonal. Okay. Now if we consider Cartesian coordinate system, so in Cartesian coordinate system there are 3 axes x, y and z, okay, and 3 coordinates, that is x, y, z. So these 3 axes are mutually perpendicular to each other. So Cartesian coordinate system is also called as the orthogonal Cartesian coordinate system. Okay. So here we have defined given the definition of the orthogonal coordinate system. So when system is orthogonal, then what about the unit vectors? So from unit vectors we can also define the orthogonal coordinate system. So in orthogonal coordinate system we write E1 cap dot E1 cap, okay, equal to E2 cap dot E2 cap equal to E3 cap dot E3 cap, that is equal to 1. Okay, this is for similar vector and dot product. Then write this E1 cap dot E2 cap equal to E1 cap dot E3 cap equal to E2 cap dot E3 cap, and is equal to 0. That means dot product of dissimilar vectors are 0. Similarly, we can write the cross product. So cross product E1 cap cross E1 cap equal to E2 cap cross E2 cap equal to E3 cap cross E3 cap, and cross product of similar vector are always 0. Then we write E1 cap cross E2 cap equal to E3 cap, then E2 cap cross E3 cap equal to E1 cap, and E3 cap cross E1 cap equal to E2 cap. Okay, well, here the unit vectors and their dot product as well as cross product comes in this manner, then the system is orthogonal. Okay, so we have to write here length element in orthogonal system. So this is the length element, and we have to write this in orthogonal. So dl square equal to, I will write this using this identity or using this unit vectors. We can write or express this length element or square of the length element in orthogonal system. So this is G11 du1 square plus G22 du2 square plus G33 du3 square. Okay, because this du1 du2 this similar are get cancelled, and we will get the length element in orthogonal system is dl square equal to G11 du1 square plus G22 du2 square plus G33 du3 square. Okay. Now next we see the relation between scale factor and metric coefficients. Relation between scale factors and metric coefficient. Okay, so you know that this G I J, write this G I J equal to daba r bar by daba ui in daba r bar by daba uj. Write this G11 equal to daba r bar by daba u1 into daba r bar by daba u1. Right? So this daba r bar by daba u1 is equal to h1, and this is also h1. Write this h1 into h1 equal to say h1 square. Right? So this becomes, that is h1 square equal to G11, or we write h1 equal to root G11. Right? So this is the relation between scale factor and metric coefficient. Similarly, we write this h2 equal to root G22 and h3 equal to root G33. Okay? So this is the relation between scale factor and metric coefficient. This is the length element in orthogonal curvilinear coordinate system. Right? So with this lecture I stop here. Have a good day.